to look at is how you evaluate an action in football. And I'm going to start with, or not just actions actually, how you evaluate a football player in general. And I'm going to take this actually from a historical perspective. So I'm going to go through the different models that have been used over time and how they've worked and the ones that haven't worked and how they've got better and how they've improved and so on, up to the point really where we are today with value models. And so everything we look at today, though we're in the sort of tracking data part of the course, everything we do today is to do with event data. So the StatsBomb data and the Y-Scout data that we started the course looking at. So I'm going to start with plus minus models, which are basically you get a plus whenever your team scores a goal and you're on the pitch, and you get a minus whenever the other team scores a goal and you're on the pitch. Then I'm going to look at regressions on actions. That's trying to use what we looked at in lectures 2 and 3. We looked at how Poisson regression can be used to find out what a good action is in football, or what's a good thing to do. Is it good to pass the ball a lot? Is it good to do a lot of crosses and so on? You can use a regression model to try and find out what good actions are and evaluate players that way. I'm going to go into that. Then I'm going to look at player radars, or basically ranking of players on the actions they have. So this is more based on the event data. These first two, this first one is based on overall performance. This second one is based on some count of actions. These ones start to be based on the actual event data that we look at. Then I'm going to come into this, what you might call the next generation of models for evaluating actions. I'll look at the Markov-based model, and I'll look at value models. And the value models is very much what Lotte and Jan do in their lectures, if you look at the webpage. We'll have a break 11 to 11:15. Maybe I'll stop a little bit later because we've started a bit later. Maybe have a bit of a shorter break so we get everything done. Please ask questions in the chat section. There's a chat section here too. I'm just opening up now so I can see if you ask any questions. And where possible, I'll answer them as I go. I'll try and take a reasonably slow pace, but please just stop me if you have any questions. Rodrigo wants to know if you should have your video off. Well, I've closed all the videos, so I can't see you anymore. So you can have it on or off. I think it's off. So when we have the tutorials, I say on, but now if we're having a lecture, then it's off. So thanks. Good question. Okay, plus minus models, we'll start there. So this is the first models that were ever used for evaluating football players, and they still are used to evaluating football players. In fact, I know certainly one of the absolute biggest clubs in the world uses plus minus models to evaluate and sign players. And it's not the one of the ones that's doing particularly badly either. It can be a very good tool for working out, in particular, if you're looking for young players, how they're contributing to a team's performance. The idea is as follows. So I've taken an example here. So imagine, and let's just start with a very naive plus minus statistic. This is one that I know, for example, this is one that my son uses, for example, when he's evaluating his own performance in the team. They have a lot of substitutions in under 18s football. There's lots of substitutions, so players are coming on and off, and you can look to see how many goals you concede when you're on the pitch and how many goals you score when you're on the pitch. And I certainly know that the kids I've trained previously do this, so they evaluate their own performance based on what happened when they were on the pitch. Now, there's definitely limitations to this, but it can give an overall picture of how much you're contributing, because obviously it's not always one player that scores the goals. It's often the strikers which score the goals, but how are the defenders contributing? So here is an example. So imagine we have two games. In game one, the player plays for 60 minutes. The team concedes 1 goal. In game 2, player plays for 30 minutes and the team scores 2 goals. I'm going to have to, okay, so the plus minus rating for the player on the pitch is, first of all, this is the 1 goal he conceded here, and we divide it by the 60 minutes. So -1 for conceding a goal divided by 6, plus 2 the 2 goals which were scored here, divided by the 30 minutes that he was on the pitch in the second one. All of it times 90, and then you get plus 4.5. You don't need to do the times 90, but it's nice to normalize it in points per minute, and you get plus 4.5. Now, if the team lost the first game 1-0 and won the second game 5-0, the PM rating when he is off the pitch is 0 for the 30 minutes he was off the pitch in the first match. We'll say the matches are 90 minutes long, so there's 30 minutes he wasn't on the match. The match result was 1-0, so there was 0 then. And then when he wasn't on the pitch for the first 60 minutes of the second match, that's the 60 here, the team scored 3 goals. 5 minus 2 is 3. And we times that by 90, and that's also plus 45. So this is an example from a paper here, which you can look up afterwards. But in this particular case, it happens that he has the same rating when he's off and on the pitch. This method can be very useful just for evaluating players within a team. It becomes much more difficult when you're comparing between leagues. For example, if my son manages to be on the pitch when the team scores 3 goals, that's slightly different than Messi being on the pitch when they're scoring 3 goals, because the level of football is different. So there's nothing, doesn't include anything to do with the level of football. So it ignores the ratings of the other players. So you actually could find out that a particular player was good. It ignores the opposition strength. It's only really for the relative strength of the players in the team, and it doesn't account for anything to do with the match situation. So there's a lot of limitations to this naive method, but it's certainly a good starting point. What you can do is, and this was proposed first by Dan Rosenbaum, or it's been proposed a few times further, is you can be a bit more rigorous about this approach by using linear regression. So Dan Rosenberg was probably the first person to publish details of this, and he published on a blog. We're going to find that quite a lot of the references we look at today are published on blogs. What he does is his method involves splitting each match into observations where no substitutions are made. So that's exactly the same as what I did in the naive version. And then running the following simple linear regression. So this is regression yi. I think I have this here. Yi is the goal difference during this particular segment. So you have to split it up into different segments. Yi is the goal difference in that particular segment. Xij is whether the player is playing. And if the player is playing in the home team, then Xij is 1. If the player is playing in the away team, Xij is -1. That's because you want to reverse the effect when the player is playing for the other team. Then you have an epsilon, which is the error in the whole process. And you have some parameters. So the idea is that you're going to estimating these parameters, which are going to rank the players. So this is the data, you know the goal difference. For example, in the first example, they let in 1 goal. So this would be -1 divided by 60, as we did before. You know if the player is playing during that segment, and you want to estimate the parameters both for the player and for the home advantage in this problem. And you set it up as a linear regression problem. Here's just to give you a feeling for this. Here's my linear regression. Again, I've labeled all of these things here. Here's what this linear regression would look like. This would be a data frame in Python, for example, where you'd have the minutes played in the particular segment of the match. So this might be the first 60 minutes of the match. Then and during that time, the home team scores 2 goals. So you have 2 divided by 60 is the yi, that's the goal difference. Then I've just listed 4 of the players, 2 of them for the home team, 2 of them for the away team. And in this case, player 1, player 2, and player 4 are on the pitch. And so all of them, so in each case, this will be 1 here. It will actually be, wait a minute, I want to get this right. It will actually be -1 for the opposition players here. be -1 for the opposition players, and player 3 isn't on the pitch. And at minute 60, player 4 is substituted out and player 3 comes in. So 4 now has zeros and player 3 has -1 in there. And on the 68th minute, I say that player 5, who isn't shown here, comes in for player 1, and you have a 0 there. And so you have this big table, and you can just do a normal linear regression on this big table in order to estimate the parameters beta naught and beta j. And beta naught is the home advantage, not particularly relevant for evaluating the players, but it will pop out. And beta j is now the player contribution, and that's what you find. So the higher the value of beta j, the more you contribute to your team's performance. This is very nicely reviewed in Lars Havtum's paper here, which you can look up. He did a nice review 2019. He's also got a video on the Friends of Tracking explaining some of the details of this, but the review is very nice and straightforward. One interesting thing here, I think, is how you do the fitting. So if you've watched my earlier lecture about linear least squares, you'll see, I mentioned this, that when we normally fit this type of regression problem, what we do is we minimize the sum of squares. This expresses the sum of squares for this problem. But the problem with this, the problem with just doing this simple minimization of the sum of squares, which would be the maximum likelihood, the problem is that you have so many parameters, beta j, because you have so many different players. So what is recommended to be done in Lars's article is that you also add a term here. So this is the normal maximum likelihood estimate, which you have here, but you also add a term here which punishes if you have too many beta j's. So if a particular player is just average, you can set that player's beta j to 0, and then it won't contribute to the sum of the squares. And this is actually, and this came up a lot in the when you did your exercises for the last project. That was a logistic regression problem, but lots of you use the machine learning toolbox, and machine learning toolboxes tend to include this term by default, and then you get different results where actually parameters are punished very heavily here, as opposed to the traditional maximum likelihood estimation, which is done by the stats models tool, which doesn't punish having too many parameters. So that was actually why you often didn't find any effect of passing in the, if you use the machine learning toolbox scikit-learn when you did your fitting, because it punished having the parameter which described the passing. So that can be, whether you use this term is sort of, it's more of an art than a science, to be absolutely honest. There's I found this quite funny because this makes it sound so complicated. A Bayesian technique of regularization known as ridge regression or Tikhonov regularization implies that one minimizes this thing. This corresponds to using a Gaussian prior distribution stabilizing the estimated ratings, both in cases with observations and when multicollinearity is present. I mean, that's a frightening sentence. But what it basically means is if you've got too many parameters for too many players, you're overfitting your model. And this term helps you avoid overfitting your model. And there is some theoretical justification why that might be a good idea. So this is the usual maximum likelihood minimization, and this is a punishment for too many players. Most players, you can basically say that most players are average, and that's nice for you because you'd like to have lots of zeros here, that they're just average contributions. Then you actually find players that stick out properly. Lars also has some nice videos where he shows how this works, and he actually has some rankings of players. I will put up a link to that at the end of this. Okay, so this doesn't, and what I really want to say, I forgot to put in the rankings here, because what I really want to say, it doesn't really work that well. You have a lot of problems just because there aren't many substitutions in football. Going back to my son's team, it can actually work pretty well because there's so many switching backwards and forwards. although the opposition tends to vary in quality a lot. So maybe it doesn't work from that perspective. But anyway, it works when you have lots of substitutions. It works reasonably well in basketball, for example, but it doesn't work as well in football because of the lack of substitutions and the lack of variation on which to fit the model. So what's the next stage? Are there any questions about that? Okay, so what's the next stage? Well, that's just evaluating the overall performance when you're on the pitch. The next stage is to actually start to look at actions. And this is one of my favorite scientific articles about this, actually, or it's very well written and very funny as well, if scientific articles can be funny. And I wrote about it in Soccermatics. So the EA Sports Player Performance Index came about quite a few years, over 10 years ago now. The question was, for a fantasy football game, and they were developing what is now the fantasy football game, how do you rate the players in that fantasy football game? Now, anyone who's played fantasy football, the one that's available from the Premier League now, might be somewhat frustrated. If you're an analytics person, you might be somewhat frustrated by the way that the points are handed out. Basically, there's a lot of points for goals and assists. There's points for clean sheets. And then there's a few extra points for something to do with performance. And it doesn't really take into account the real skills or the real contributions of the players. It's very hard to get points with a defender. Defensive midfielders in particular give you hardly any points in fantasy football. But what they wanted to solve, what Ian McHale and his colleagues wanted to solve was, well, how can we actually make this fair? How can we really assess what the players do, which aren't goals and assists, and value those things? So the first thing they did is they did a linear regression on the number of shots by a team. And if you look in lecture week 6, lecture week 3, I talk a little bit about how you do these linear regressions. They did a linear regression on number of shots by a team as a function of the number of crosses, dribbles, passes, and so on made by the team. And basically the coefficients in that linear regression, they relate to how important they are in generating shots. So if you have a number of crosses, you're more likely to have shots. So this is the correlation coefficient between crosses and shots, dribbles and shots, passes and shots. Also, for example, if the opposition have a red, then you can also have a red card, then you can also have with shots. And you see that opposition having a red card really increases the rate at which shots occur for your team. Even the opposition yellow quite increases, the number of opposition yellows really increases the number of shots that you have. There's a cause and effect problem here. But anyway, this is a way of trying to work out how these different actions that take place lead to shots. And I quite like this because you can do the following. You can say, well, one cross, if you divide the coefficient for crosses by the coefficient for passes, you can find that one cross is as valuable as 15 passes over an entire season. And getting sent off is like doing minus 42 interceptions. So it's like missing 42 interceptions is the same as getting sent off if you divide that coefficient by that coefficient. So I quite like that. I like the idea behind the approach, but it doesn't really work for the reason that reasons we've discussed in some of the other lectures, that the value of passes changes, and you need to know where a dribble takes place. This model would just say you should just keep crossing in the ball all of the time, and that doesn't really reflect what you should do to play good football. So there's some weaknesses in this model, and those weaknesses were reflected in how the points came up. So what they do first is they do the linear regression. Then they basically count the number of crosses, dribbles, passes, yellow cards, red cards by each of the players. And they came up with the following thing, that this was the 2008-2009 season in the Premier League. This was Cristiano Ronaldo's last season at Manchester United, where he was top goal scorer. Rio Ferdinand, Vidic, Giggs all made key contributions to that side. It was good year for Jamie Carragher, Steven Gerrard, Dirk Kuyt at Liverpool, and Gareth Barry as well. So I named some of these amazing players that played in the Premier League this season. And well, who did they come up on top? Well, it was the Fulham goalkeeper, Mark Schwarzer, that it ranked as the best possible player. Gareth Barry in second place, Sol Campbell, who was playing for Portsmouth at that time, in third place. And they weren't really the list of who the fans would call the best players who made the biggest contributions. And I think that's always a problem. I'm a great believer that you should also listen to the fans and the coaches in these types of assessments. And these models didn't really support that. They went on and they made a few adjustments. They added goals, clean sheets, wins, etc. And that improved it a bit. It turned out that Nicolas Anelka was the best player that season, which certainly the fans didn't agree with. But once you start doing that, you're actually going back to the fantasy football approach, and it's not really principled in some way to do that. So again, this is an interesting approach. It can be useful for some particular problems you're interested in, but overall, it doesn't give a successful rating of players, not one that anyone would really agree with.